So for this first problem, we're given the initial term, we're given the infinite series, and the goal is to find S2. Well, we know that this is an infinite series, and we know that this is the formula that we can use. And so what if we take this first term, plug it in there, take the actual value of the series and plug it in on this side there, and then we can try to find R. Now I'm trying to get R alone. So what if I multiply both sides by 1 minus R, and over here 1 minus R like that, because then this would knock out on this side. And now I have 1 minus R times this equals that. So what I'm going to do is I am going to divide both sides by this fraction here. I'm going to put it there, and I'm going to put it right there. So all of this here on a calculator gives you back 1/4. And if you solve this equation for R, you'll discover that R is 3/4. So now look, we want S2, but we know that S2 is nothing more than A1 plus A2. Now I know what A1 is. A1 is this fraction here. So how do I find A2? Well, A2 is going to be A1 times R. And that should be what we get, because we have S2 is A1 plus A2. A1 was given, and then plus, and this is A2 because it's A1 times 1 copy of the common ratio, which was 3/4. Calculator gives us a final answer of this right here. Okay, now for this problem, we want to find the value of Q. That's what we want. We want to find Q. Let's begin by dividing both sides by 1 minus pi to the power of 3. Okay, so I divided both sides by 1 minus pi cubed, so it's down there. And I multitasked, and I took out the GCF of these guys, which was this here, leaving us with this inside. It's 12 because 6 plus 12 gives you the 18. Now on this side, the idea is to replace all of this by your series formula, which is this guy here. But we have to establish what A1R and N are. So let's see, let's make some facts here in purple. Can we agree that the common ratio is going to be pi to the power of 3, because it's right there? Now, as for the number of numbers, right, the number of numbers, can we agree that it would be 2Q minus 4, because it's going to be top minus bottom plus 1. So it's 2Q minus 5 plus 1, which is 2Q minus 4. Now, what's playing the role of the initial term? The initial term is whatever you get when you plug 5 in for H right there. And if I take a 5 and put it in for H there, it's 5 minus 3, which is 2. And then 2, it's going to be 2 times 3, because it's this guy squared, because 5 minus 3 is 2. And then pi cubed squared would be pi 6. So this is actually square root 2 pi 6. So this is going to be our initial term, which goes there. R, the common ratio, is right there, pi cubed. And then the number of numbers is 2Q minus 4. So why don't we go over here now and make those changes? So all of this here is going to get replaced by this formula right there with these guys plugged into your formula. Now this here just collapses, it just copies and pastes. Now let's make a comparison between both sides of this equation to see what can cancel out. Let's do some cancellation with a green marker. Compare both sides. Can we agree that 1 minus pi cubed knocks out? Similarly, this guy here, those knock out. Even the 1 minus knocks out. All you're left with is pi to the 12 equals pi cubed to the power of 2Q minus 4. And the pi's knock out now. And you can actually distribute the 3. So this tells you that 12 equals 6Q minus 4, minus 12 rather. See, I almost messed that up like that there. And then solve for Q, and you'll see that Q is 4.